Hi guys, so we're starting Unit 7 today, which is all about systems of equations. So hopefully this is a nice little review on how we solve systems of equations, and then we're going to get into solving systems of equations with three variables, which we reviewed in Algebra 2, but we'll look at it again here when we get to 7.3. But we're going to start here with 7.1. Two objectives for 7.1. We're going to use the methods of substitution. So we're specifically, spelling, right? And graphing to solve systems of equations. So for 7.1, we're specifically just using at the substitution method of solving systems of equations. And then we're going to use systems of equations to model and solve real-world problems. So how can I use my systems to actually solve these real-world problems? Okay, so first it says, oftentimes in business and science, it is useful and necessary to solve a system which involves two equations and two variables. The solution to this type of system is an ordered pair that satisfies each equation, meaning your answer needs to be written as an XY coordinate point, unless it's a word problem, in which case your answer needs to be answered in a sentence. But that XY coordinate point works, it has to work for both equations. It can't just work for one, it has to work for both. Okay, so like this first example here, deciding like whether or not 1, 2 is a solution. So 1, 2 would be a solution if it works for both the top equation and the bottom equation. And really what you're after here is, what that means is, do these two lines, right? Because these are both linear functions, so they're lines, right? Do these two lines cross at the point 1, 2? So it's really what you're solving for, is where do these two lines cross? Okay, so I have to plug 1, 2 into both of these equations and see if it works. So let's try the first one, which is 2 times x, which x is 1, minus 3 times y, and y is 2, and it equals -4. So I'm just going to simplify this. 2 times 1 is 2, 3 times 2 is 6, equals -4. So I get -4 equals -4. So 1, 2 works for the first equation. Now we need to see if it works for the second equation. So having it work for just the first equation just means that, hey, the point 1, 2 is on this line. But I also have to make sure it's on this line because that's where they cross. Okay, so let's try the other one. 2 times x, which is 1, plus y, which is 2, equals 4. So I have 2 plus 2 equals 4. So 4 equals 4. So this point 1, 2 is on both of these lines. And since it's on both of the lines, then 1, 2 is a solution. So 1, 2 is a solution. And so the big key here is that 1, 2, it has to work for both equations. If it only works for one, it's no good. It has to work for both equations in order for it to be a solution. Okay. So that's just verifying if something is a solution or not. Most of the time, your job is to find what the solution is, not just verify that something's a solution. So let's look at that. I'm not going to go through this super, intensely. We know how to solve by substitution, right? Solve one of the equations for one variable, and then plug that into the other equation, and then just solve. Once you know what one of the variables is, plug it in, find the other one. So we're going to look here, and because we're specifically looking at the substitution method here, we really want to add these two equations together and have it be super fast. But we're going to solve by using the substitution method, so just make sure you pay attention to what method we're using, right? So I'm going to take one of these. Actually, I can solve either one of them. for a variable, and I can choose, do I want to solve for x or do I want to solve for y? And it doesn't matter. Okay, so in this case, I'm going to solve this top one for y. So y equals 4 minus x. Right, I just subtracted the x to the other side. So y equals 4 minus x. Or you could also write negative x plus 4. Either way is fine. So now that I know what that is, I can take that and plug it in right there. Okay, so that gets me x minus 4 minus x equals 2. So I rewrote equation 2, just replacing y with what y equals. So this gives me x minus 4 plus x equals 2. I'm going to add the 4 to the other side and combine the x's, so I get 2x equals 6. So x equals 3. Once I know what x is, I can take that and plug it back into one of these equations. So I'll just do this one, right? The y is equal to 4 minus x, but x is 3. So y is equal to 4 minus 3. So y is equal to 1. So the solution here is 3, 1. So it's not a word problem, so my answer is going to be written in as a point, as a coordinate point. And here this tells me this is the point where these two straight lines cross. Okay. So if I were to graph the lines, they would cross here at 3, 1. If you're going to do this on your calculator, you would solve each equation for y and then enter them into your calculator. So y1 would get you negative x plus 4 or 4 minus x, it doesn't matter. And then y2, if I solve it for y, I would get x minus 2. And then I would graph those. Okay, so then I would graph. After it's graphed, you're going to go second. That's a button, right? And then trace. Also a button. And you're going to choose option 5, which is intersect. So I want to find where do these two graphs intersect, right? It'll ask you to do the left bound and the right bound and the guess and all that stuff. And then it'll tell you the point of intersection. So you can check your work on a graphing calculator that way. And here it says use a graphing calculator to verify. Okay, so now let's look at how we actually kind of use these more in real life, and maybe some like, okay, what if they're not linear? Okay, so solving the system by substitution. A total of $12,000 is invested in two funds paying at 9% and 11% simple interest. The yearly interest is $1,180. How much is invested at each rate? So my goal is to find how much is invested at 9% and how much is invested at 11%, right? I have 12,000 total. How much of that is in the 9% and how much of that is in the 11%? So those are my two variables because that's what I'm trying to find. So we can let x be the amount of money invested at 9%, which means then we can let y equal the amount of money invested at 11%, right? Those are the two things I want to find, so those are my two variables. Okay, so I know two things. One, I know that all of the money invested at 9% and all of the money invested at 11% equals $12,000. So I know that x plus y is equal to 12,000, right? Because that's my total amount of money invested. Then I also know, and remember we don't use percents, right? I would have to convert these into decimals. But I know that, hey, I have 9% of money of interest times however much I've invested at 9%, plus I have 11% of interest at the 11%, and I know that the total amount of interest is $1,180. So now I've created a system of equations, right? They're stacked. I have my x, my y, my equal sign, my constants. They're stacked, and I can just solve. So let's just solve this top one for x, because so x is equal to 12,000 minus y. I'm going to take that and I'm going to plug it in. So 0.09 times x, but x is 12,000 minus y, plus 0.11y equals 1180. I'm going to distribute. So 0.09 times 12,000 is 1,080 minus 0.09y plus 0.11y equals 1180. So I'm going to subtract that 1180, which gets me 100. Sorry, I'm going to subtract the 1080, which gets me 100. And the negative 0.9 plus 0.11 is 0.02y. Divide both sides by 0.02, and I get y is equal to 5,000. So I've invested $5,000 at 9%. Sorry, at 11%. Y is 5,000. Now I need to find x. So x is equal to 12,000 minus 5,000. I'm sure that you could have done this part in your head, right? And I get x equals 7,000. So because this is a word problem, though, we need to actually explain what these values mean. Okay, so I can say something along the line of $7,000 was invested at 9%, and $5,000 was invested at 11%. And that's enough, but it's just explaining your values, right? If you just say x is 7,000, y is 5,000, I don't know what that means. So the importance of using a sentence when you're answering a word, when you're answering a word problem, just make sure you're using that sentence. Okay, so we've looked at, right, when I have two lines, two straight lines, they cross once, right? I mean, you can't have more than two lines, or you can't have two lines crossing more than once. What if, though, you don't have two straight lines? So like here, I have x squared. So that tells me that's a parabola, right? And then I have a linear function. So there's three options that can happen with a parabola and a line. The first one is I can have a parabola, more or less, right? And then a line that just cuts through it. In that case, there would be two solutions, right? These two graphs cross twice. Another option is I could have my parabola and a line, oh boy, that just touches at one point. In that case, there would be one solution. Or I could have a parabola with a line that doesn't cross at all. And in that case, there would be no solutions. So there's kind of three options here on what we can see if we have a parabola and a line. Okay, so this is a parabola and a line. It doesn't mean that we can't solve it. It just means that, we might have to do a little bit more work. So in this case, because we're using substitution, I'm going to solve this for y. So I'm going to subtract that 2x over, so negative 2x minus 1, and then divide everything by negative 1, and I get 2x plus 1. So since I know that's what y is, I can take this and plug it in right there. Okay, so this leaves me x squared plus 4x minus, don't forget to add that parenthesis after a minus, 2x plus 1 equals 7. I need to distribute this negative now, which is why it's so important to have the parentheses there. Okay, so x squared plus 4x minus 2x minus 1 equals 7. I'm going to get everything onto one side, start combining things. So x squared, I have a 4x minus 2x, which is 2x. I'm going to subtract the 7 over, which gets me negative 8 equals 0. Luckily for me, this is factorable, so I don't have to use quadratic formula. I can just factor it, two numbers that multiply to negative 8 and add to 2. It gets me a positive 4 and a negative 2. So I have x is equal to negative 4 and x is equal to 2. So what that does is it tells me, okay, there's two solutions. One of them has an x value here at negative 4, and one of them has an x value here at 2, right? So that tells me that I'm going to have negative 4 comma something as one solution, and then 2 comma something as another solution. So let's figure out what those somethings are. So let's just start with our first answer. X is negative 4. I'm going to use this equation because that seems way easier, right, than trying to use the other one. So I have y is equal to 2 times negative 4 plus 1. So y is equal to negative 8 plus 1. So y is equal to negative 7. So negative 4, negative 7 is a solution. That is a point where these two graphs cross. Now let's find the other one by using the point 2. So I'm still going to use that 2x plus 1, but now I'm just going to plug in 2 instead. So y equals 2 times 2 plus 1, right, which is 5. So 2, 5 is the other point. So in this case, there's two solutions. And, so that tells me it's this guy, right? And one of the points is negative 4, negative 7, and the other point is 2, 5. Okay, let's look at another one of those where we have a parabola and a linear function, right? So here I have x squared and then a linear. So I'm going to solve this top one for y because y is positive. So y equals x plus 4. So I'm going to take that, plug it in right there. So this gives me x squared plus x plus 4 equals 3. Don't have to put the parentheses if it's plus. I only have to put the parentheses if it's negative because I have to distribute that negative. Okay, subtract the 3 over and I get x squared plus x plus 1 equals 0. Now, this sucks because this is not factorable, right? There's no number that multiplies to 1 but also adds to 1. So if I can't factor, I have to go quadratic formula. So using the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I'm just going to start plugging in my values. B is 1, so negative b is negative 1, plus or minus the square root. 1 squared is 1, minus 4 times a, which is 1, times c, which is 1, lots of 1s, over 2 times 1. So negative 1 plus or minus the square root. 1 minus 4 is negative 3 over 2. So when I take the square root of negative 3, right, this is imaginary. but I want to know where does it physically cross, like, right, where do these two graphs physically cross? So since it's imaginary, that means that this is no solution. These two graphs do not cross in the real plane, okay? So it means it's that second option, right? Where, just to kind of show you, one of the graphs is doing this. So here's the parabola. And then the other one is doing this. So they never intersect. So because they don't cross, right, it's that third option of a parabola and a line. Because they don't cross, these two are, it's just no solution. I don't know why I put S, just no solution. It's fine. Okay. So what we're going to do now, hopefully that we feel good about that. Hopefully this isn't anything crazy new, right? Factor it if you can. If you can't factor it, quadratic formula. Let's look at how do we solve using technology, aka our graphing calculators. Okay, so step one says solve the equations for y, right? So you want to get both equations equal to y so that you can enter them into your calculator. Step two, always make sure that you adjust your windows if you have to so that you can actually see the points of intersection. And then you're going to go second calc or second trace, right? And then select the intersect, which is number 5, like what we wrote down earlier. And then you do your first curve, your second curve, and then guess, and then find that point of intersection. So we're going to just practice that. Oops, wrong button. We're just going to practice that here, right? It says solves the system of equations. So here, like, I don't want to do this by hand. I don't know, like, I don't want to graph natural log of x and then, like, figure out when that's equal. I just don't. It's just a pain. So basically what we're doing, like, I'll just show you. If I were to take this and plug it in for y, right, I would have x plus natural log of x equals 1. Awesome. I have no way to solve that algebraically, right? At this point, like, can't solve this algebraically. So if you can't solve it algebraically, then you have to use your graphing calculator. And so we're going to figure out our first graph is going to be the natural log of x. And then our second graph, I have to solve this for y, so it's going to be negative x plus 1. And we're going to graph this and figure out where these two lines cross. So go ahead and get your graphing calculator out if you don't have it yet. And let's look at this. Okay, so let's look at a calculator. So here I have under L1 is the natural log of x, and under y1 is the natural log of x, and then y2 is negative x plus 1. So I graph it, and it looks like this. Now from here, it looks like it crosses at 1, 0, but we can't always trust, the graph. It could just be really, really close to 1, 0 or whatever. So we're going to find out using our calculator. So we go second trace or second calc. And then number 5 is this intersect. So I hit number 5. Then it says, is this the first curve? If you have a color calculator, you can go by color, right? Is the blue one the first one that you want to use? If you don't have a color calculator, just look up here. Is this the equation that I want? And we say, yes, it is. Oops. Right? Yes, there's the blue one. Yep, that looks good. And I hit enter. Then it says, is this the second equation that you want? And in this case, yes, right? I only have 2 equations, so it's pretty easy. But like sometimes if you have like 5 or 6 equations and you want to find the intersection of 2 of them, you have to know, which one you're looking for. But here, yes, this is the second equation. I hit enter. Then it says guess. Because these only cross at 1 point, I don't have to guess. I'm just going to hit enter through that. And I get 1, 0 as my point of intersection. Okay, so right, 1, 0. is the solution. So if you cannot solve it algebraically, using your graphing calculator can be really, really helpful. Again, hopefully this is all just good review. The last thing we're gonna talk about is our break-even analysis, which if there's any of you that are thinking about being a business major or, creating your own business, opening your own store, anything like that, this is something that you will use a lot, right? The break-even analysis. This is like, how many units do I have to sell to break even, right? How many units do I have to sell to start making a profit? Things like that. So let's say a company produces and sells X amount of product, whatever it is. Okay, my revenue. This is the price per unit. Okay, so this is like when I say price, I mean like the what I'm selling it for, right? The price that a customer would pay per unit. That is what is coming in. That is your revenue. Your cost is any equipment cost that you have to make the product plus the cost per unit, right? There might be a certain amount of cost per unit associated. So equipment cost plus the cost per unit. So your break-even point is when those two things are equal, right? If you sell less, then if you sell less dollars than the amount of money it cost you to make the product, then you're in the hole. If you sell more than what it cost you to make, then you're making profit. But that break-even point is at what point do I need to, how many units do I need to sell to break even, right? To have no debt. And then obviously your profit is the difference between your revenue and your cost. So how much money are you making? So let's look at an example using this, and then we'll be done. So it says a small business invests $10,000 in equipment to produce a new soft drink. Each bottle of the soft drink costs 65 cents to produce and is sold for $1.20. How many bottles must be sold before the business breaks even? So the first question here says, write the cost of the function, okay? So if we remember that the cost is equal to the equipment cost, which is $10,000, plus the cost per unit. And in this case, the cost per unit, it's not 0.065. That'd be nice though, huh? 6.5 cents. The cost per unit is 0.65x, right? Because x is the number of units. Part B says write the revenue function. So the revenue function is just, hey, how much are you selling it for and how many units are you selling? So this is just $1.20 times x. And then the last part says determine the break-even point and describe what it means. So the break-even point is when my revenue is equal to my cost. So I'm just going to set these two equations equal to each other and solve, right? So revenue is 120x, cost is 10,000 plus 0.65x. So I'm going to subtract 0.65x to both sides, which gets me 0.55x equals 10,000. Divide both sides by 0.55, and I get x is about 18,182 bottles. Right? So remember that when we're talking about physical objects, we always round down. Because like 0.3 of an object is not a full object. And so you're just wanting to know how many whole objects there are. And then it says describe what this means. Okay, well, this means that the company needs to sell 18,182 soft drinks to break even, right? If they sell less, they're losing money. If they sell more, they're making a profit. Maybe we put that. If they sell more, they make a profit. And I'm kind of out of room, but maybe you can add into if you want, if they sell less, right? If they, oops. If they sell less, they lose money. They are losing. So using that break-even point to kind of help you gauge, especially, like I said, for my business majors, anybody that's wanting to start their own business or run their own company or anything like that, this is something that you end up using a lot to try to help project your numbers and kind of figure out the break-even point of your product, but also how much profit you can make from your product. That is it, you guys. Nice and short and sweet. If you have any questions, make sure that you reach out and let me know, and we'll do 7.2 later.